Hello everyone. So in this video, I will going to discuss the trash problem of educational code forces round 95 div 2. So what this problem is all about? We are having a room which can be represented as a coordinate axis OX, and then there are some n piles of trash in the room located at some distinct positions which are denoted by pi, and then we have to do this total cleanup, and the total cleanup is described as that there can be no like we can locate all the piles in no more than two different positions, right? To achieve this, we can perform some moves, and one move is described as that we can choose the coordinate of some pile, and then we can move that pile to its right by one distance or to its left by one distance. To achieve this total cleanup, we are doing these moves, and then we're also given some queries of two kinds. 0x query denotes that we are removing a pile which is located initially at position x, and then 1x denotes that we are adding a pile at position x, and then before the queries or after before the query and after the query we have to answer that how many minimum number of moves we need to achieve this total cleanup. So let me explain this problem here with the help of example. So we are initially having a room, and then here in the first example we are having a pile at some positions 1, 2, and then here at 6, and then here at 8, and then here at 10. So here these are the piles in the example. So we have to move this pile using our moves, and in such a way that we can collect all the piles in two locations. So if we see the distance of the piles from each other, so this is distance 2 from each other, and this is at distance 4 from each other, and this is at distance 2 from each other, and this is at distance 2 from each other as well. So now if now it is optimal always in this problem to move the piles which are close to each other, otherwise it will have more number of moves. So if I move this one pile to 2, I will have two number of moves. I will have one number of move. This is one actually, sorry. So and then I will move 6 to 8, then it will take 2 moves, and if I move 8 to 10, it will take another 2 moves. So in total I will need 5 moves. And in the next query they are adding at position 4 1 pile. So now this distance will not be like this, it will just modify a little bit to like this. So we'll have, instead of one distance earlier, we will have now two distance. So these are located at distance 2, and this is located at distance 2. So now here we can choose any of these two distances, and we can avoid that two distance, and then rather to choose other distances. So if I choose 1 and I choose 2, and I am already choosing this 2 and 2, so I have to do 7 moves, which is the answer. So in total, in summary, what this problem is all about is that we have to just avoid the maximum distance between any two piles, and our answer will be the distance between the first pile and the last pile, and minus the maximum distance. In the earlier it was 4, in now it is 2. So this is 9. Here the distance between the first and the last pile is 9, minus here we will and subtract 2, because 2 is the maximum distance between any two adjacent pile. So this is the way we will gonna do this problem. So since there are tensor 5 queries, so we will gonna use a data structure which can help us to delete elements and also add elements in the set in this room, and we will gonna use sets for the coordinates because the coordinates are unique, but the differences and the distances is not unique. So we're going to use a multi-set for the distances. So as can be seen, the queries are of two types. So the queries are in one of the queries we have to add a pile at some location x. So if I add a pile at this location x, and let us say if I already have two piles, one in the left and one in the right, so then initially the distance between the previous and the next is I have to remove from the set of differences, because this is gone now, this is not there, and I have to add this two distances, the distance of the newly added file and the previous file, and the newly added file and the next file. Similarly, this is the operation of add. Like if I'm adding the files, so now if I'm deleting the file, so what is there? Let us say I'm deleting a file which is also in the left and the right of some file. Let us say I'm deleting this file, so then I have to delete these two. This will be like opposite to this, opposite to the add operation. I have to delete these two, and then I have to add instead the distance in the distance and multi-set, this distance between the next and the previous. So this will be the delete operation. So let us look at the code to understand it a little bit better. So here, if I see the add operation, so I am using a set for the coordinates and a multi-set for the differences or the distances. So when we are doing the add operation, so we simply insert in the piles x and the coordinate, and now we have these positions. One is the position of x, one is the next position, one is previous position. So we have to erase the distance between the next and the previous, I have already told you, and then we have to insert the distance, two distances we have to insert. One is the distance of x to the previous, and one the distance of the next to the x, similarly that I have explained here. And when I delete the files, so then similarly I do this. I have this iterator which has deleted the x and now pointed to the next position. So then we have to erase two distances in the distance array. One is the this one that is next to the x, and one is x to the previous. So we are doing the same thing, x to the previous and next to the x, and we are inserting the next to the previous. We are inserting the next to the previous, this one. So here this is the add and delete operation, and after that what is the output of the result? How we output the result? So if the coordinate size is just less than equal to 1, then the answer is 0, because we don't have to move any file to any other place, because we have only one file. Otherwise the answer will be the maximum element of the set, coordinate set, to the minimum element of the set, which will denote the distance between those two, minus the maximum distance between any two adjacent files. So this will be the answer operation. So in the beginning we just add all the elements using the add operation, and while doing the queries, if our query is of type 0, we will going to do the delete operation. Otherwise we will going to do the add operations, and after that we will going to do the answer operation. So I hope you understand this. Thanks everybody. So with this note I terminate now.